Hello students, welcome again to Chemistry 101. This is your instructor Ismail Badran talking to you, and today we are going to discuss a really important subject in chemistry, which is concentration. The word concentration in chemistry means it's basically the amount of solute present in a given quantity of a solvent. You know, a solution is made basically of a solute and solvent like NaCl and water. So the concentration of the solution would be the amount of that solute in a given amount of solvent. How do you measure concentration? Concentration can be measured in different ways, but one of the most famous way is the molarity. Molarity is one of the ways to measure concentration, solution concentration. And this FIT demonstration here, fit.com, it provides you a really nice way of explaining what a concentration is here. Here you have a tank of water, and if you see, this is called a probe, a concentration probe. You move it with your hand into the solute. Now first we have nothing in the water here, so the concentration reads 0.000 mole per liter, which is the unit of concentration. You can here choose whatever you like. The solute, you can play with this at home, it's really fun. I'm just gonna choose cobalt nitrate. I'm gonna shake this and add some cobalt nitrate, and you see here the concentration is increasing in the meter. If you move this away, you add more, nothing will happen because this probe has to be into the solution. I'm adding more. See, this number is increasing. You can just play with this, decrease the amount of water or increase it. Okay, and you see what's happening here. You can even, I think, evaporate the water. So you can play with this at home to understand more about how concentration works. Now, concentration or molarity is defined as the number of moles of solute over liters of solvent, of solution. So that's N over V, okay? So the N is the number of moles of solute divided by the volume of liter of the solution. So that's basically what molarity is. So things to keep in mind. First, the volume is in liter, not liters of solvent, okay? The other thing, the molarity of solution depends on temperature. So when you prepare a solution in the lab with a given molarity, the molarity might change if the temperature of the lab changes. And also the value of concentration, like density, does not depend on how much of the solution is present. So it is an extensive property. Now, how solutions are prepared? We can easily prepare solutions of definite concentrations in the lab by using an apparatus called volumetric flask. A volumetric flask is a glass instrument in the lab that has a long neck with a mark on it. And these volumetric flasks, they come with different sizes. There's like, they go from 25 mils, there's 50, there's 100, up to even 1 liter or 2 liters of solution. There's some big ones as well. So the first thing you need to do is to calculate the mass that you need to dissolve, and you go and weigh that in a balance. You dissolve it in a beaker, okay? In an amount of water that is less than the total volume. So if you want, let's say, to prepare 100 mils, then you dissolve that solid, let's say, in 20 to 30 mils of water. You add that solution through a funnel into the volumetric flask. That's the middle picture, okay? And you keep washing your funnel and beaker until you completely get rid of the solid in the beaker, and then you complete the water to the mark, and that would be your way to prepare solutions. You will be trained in the lab, of course, on preparing these solutions. Now, here's a question we need to practice, so let's practice that. The question says, how many grams of potassium dichromate, K2Cr2O7, are required to prepare a 250 milliliters solution whose concentration is 2.16 molar? So here's the question. It says that we have K2Cr2O7. I've already calculated the molar mass of that to be 294.2 gram per mole. I'm required to prepare a volume of 250 ml with concentration or molarity equals to 2.16 molar. So basically we need to prepare a solution of K2Cr2O7 whose volume is 250 milliliter and the molarity is 2.16 molar. The unit of concentration is molar or mole per liter. That's the unit of concentration. It's mole per liter, or this is called molar. it's pronounced as molar. So here I'm asking about the volume. I have only one rule. So solution, I know that molarity is equal number of moles over volume. I know the molarity, I know the volume, I can find the number of moles, and from the number of moles I can find my mass, because he's asking about the mass. So that's my plan. So you can use this as well. The triangle method. The molarity is equal number of moles over volume. That means molarity is number of moles over volume, or molarity is, sorry, number of moles is M times V, or V is equal N over M. Here we need to find the number of moles. That means number of moles is equal M times V. But remember this one, the V is in liters, and that's very important for you not to mess up. So number of moles in this case is 2.16 molar or mole per liter times the volume. It's 250 mils, so that means it means that it's 2.5 liter, and you multiply that, you will find the answer to be. So now I know that number of moles is equal mass divided by molar mass. That means the mass is equal number of moles times molar mass. Then basically it's equal to this number multiplied by the molar mass of the dichromate, which is 294.2 gram per mole. Of course, the moles cancels with the mole, and you will have an answer of 159 grams. That's the mass that you need to weigh in your balance and dissolve it in 250 ml in order to get 2.16 molar solution. So now this is for you to, if you like, to take a screenshot of this. Here's another question that says a chemist needs to add 3.181 grams of glucose to a reaction mixture. Calculate the volume in milliliters of 2.53 molar glucose solution that she needs, that she choose for the addition. So for this question, basically, we have a solution of glucose. Okay, imagine that we have in the lab or in the hospital or wherever, we have a glucose bottle whose concentration is 2.53 molar. And that chemist wants to add from this, she wants to take only 3.81 grams. So this is in molar, and I need to take it grams, so you cannot just measure that. So the question asks you what volume you want to take from this that is equivalent to 3.81 grams. So I have 3.81 grams of glucose. The volume is unknown. The molarity is, I have the molarity is 2.53 molar. The molar mass of glucose, I have calculated that to be 180 gram per mole. So my plan here is, so I know the molarity. So from the molarity, so the molarity equals number of moles over volume. Okay. So I need the volume. So that means the volume is equal to N over M. I have the molarity, but I don't have the number of moles. But I know the number of moles is equal mass divided by molar mass. So I have the mass, which is 3.81 grams. I have the molar mass, so I can find the number of moles, and from the number of moles I can walk my way back into the volume. So let's find the number of moles first of that 3.81 grams. So number of moles equal mass divided by molar mass, which is 3.81 gram divided by 180. So that's going to equal to 2.114 times 10 to the minus 2 moles. Okay, and now you just find the volume of that. So the volume is equal to number of moles over molarity. So it's going to be equal to this number divided by molarity, which is 2.53 molar, and that should equal to 0.36 milliliter. So another way to do this is through unit analysis. If that business is too confusing for you, you can just use unit analysis. He's asking about the volume, So you write the volume equals to, and then you write what is even provided to you. I have grams and I have molarity. So you can start with the grams, 3.81 grams, and you change that into moles by multiplying by a factor that corresponds to the molar mass of glucose. So I know that 180 gram of glucose is equal 1 mole, right? So this grams goes with this grams, and then you use the definition of molarity. Molarity is 2.53 molar, so that's mole per liter, so that means 2.53 mole per 1 liter. That's the molarity, right? So this mole goes with this mole, and now this leaves us with liter. That's good. You just need the answer to be in milliliter, then you multiply by a factor, which is 1000 milliliter. Sorry, 1 liter is 1000 milliliter. You see how easy is this? So this liter goes with this liter. So basically you take 3.81 times 1000 divided by 180 times 253, and you should find this to be equal this number as well. Now we come up to another definition, which is dilution. Sometimes in the lab you have already a concentrated sample or a concentrated solution, and you want to prepare a diluted sample or a diluted sample of that solution. Okay, so concentrated or stock solutions are usually prepared and stored for use as needed, and stock solutions are usually diluted before use. And dilution is basically the procedure for preparing a less concentrated solution from a more concentrated one. So remember that dilution changes the concentration of a solution but not the number of moles. So here we have dilution. You can just bring a solution and you add water, and that will bring you diluted solutions. The idea of dilution basically is that the number of moles before is equal to the number of moles after, and because the number of moles is equal to m times v from the definition of molarity, then we say that m1v1 is equal m2v2, or m initial v initial is equal m final v final. This is the dilution formula that we use to solve dilution problems. So this question, it says, describe how would you prepare 5.00 times 10 to the power 2 milliliter of a 1.75 molar H2SO4 solution, starting with an 8.6 molar stock solution of H2SO4. So this question looks like it's a dilution problem because you are preparing a solution from another, and it's the same compound H2SO4. So you can tell it's a dilution problem. But the issue here is to determine which one is M1V1 and which one is M2V2. So this example 4.9, it says determine how would you prepare this and this. That means looks like this is the solution that you want to prepare, and therefore for me this 5.00 times 10 to the power 2 milliliter, that's V final or V2. So I'm going to write this down here. So V2 is 5.00 times 10 to the power 2 milliliter. How would you prepare this 1.75? That's also the concentration that is required, so that's M2. Sometimes it's confusing for students to determine which one is the M1, which is M2. That's 1.75. Starting from, you see, starting with that's mean M1. This is 8.61. 8.61, that's your M1 molar. So you see here, and of course, describe how would you, that means V1 is missing. So you can tell here we are going from concentrated sample, which is 8.61, that's a high concentration, into the low concentration. This is the diluted sample. So that's an easy question. Once you get this in place, you just say M1 V1 equals M2 V2. And the nice thing about dilution problems, if the volumes are in the same unit, you don't have to convert volumes. So here I have M1, which is 8.61 molar, times V1 is equal 1.75 molar times V2, which is 5.00 times 10 to the power 2 milliliter, and that should give you the answer in milliliter, right? So V1 basically should equal to 1.75 times this divided by 8.61, and that should give you 102 milliliter. Now, in these type of questions, it says describe how would you prepare. So the question is not only doing the calculations, but you need to describe how would you prepare that. So you have to write a sentence describing how would you prepare that solutions. So for that you say, I take, or you can take 102 milliliter of the 8.61 molar solution. You add it to a volumetric flask, okay, that has 5.00 times 10 to the power 2, that's 500 mils, and complete the volume to the mark. I will explain to you more in the lecture of this description process. So, you know, in chemistry there are two things. There is a qualitative analysis and a quantitative analysis. Qualitative describes things, so it answers the question of what is it, what color is it, or is it big or short, or big or small, short or big, and so on. But quantitative answers the question is how much. So when I ask you what color is it, you say red, this is qualitative. But when I ask you how much is that, and you say okay, it's 500 milliliter, that's quantitative analysis. So titration is a quantitative method that is used to determine the unknown concentration of samples. And I want you please to take a look at this YouTube video to know more about titrations. Now in titration, a solution of accurately known concentration, in other words, standard solution, is added gradually to another solution of unknown concentration until the chemical reaction between the two solutions is complete. Now we have two things in titration. We have something called the equivalence point, and also called the end point. The equivalence point is basically the point at which the reaction is complete. That's when the number of moles of the base is equivalent to the number of moles of the acid. There's something also called the end point, which is not shown in the slide, but the end point is when the color of that reaction changes. So theoretically the end point, basically the difference between equivalence point and end point. Equivalence point is the theoretical one, where end point is the practical one. And your job is in the lab is to bring this end point as close as you can to the equivalence point. In acid-base titrations, we use something called indicator. The indicator is a substance that changes color at or near the equivalence point, okay? So the famous example is the reaction between HCl and NaOH, where you use indicator called phenolphthalein that looks like a pink in acidic solution, but it is it appears pink in basic solution, but it's colorless in acidic solutions. And that indicator, the phenolphthalein, once you reach the end point, the indicator will change color from colorless to pink, and this will indicate the equivalence point where you need to stop the titration. Now, titrations can be used in acid-base titrations, okay, like this reaction, the sulfuric acid plus NaOH. Also, it could be used in redox reactions. So titration is not only for acid-base reactions. There are so many types of titrations, and one of them is also redox reactions. Here is another example of iron 2 plus ions reacting with MnO4, such as KMnO4, and that also involves a color change. The idea of titrations is that it's very similar to the dilution, where the number of moles of the acid should be equivalent to the number of moles of the base. So if you have 1-to-1 reaction, you can apply MV acid equals MV base, but that does not apply to all acid-base reactions. Like for the reaction in the front of you here, the sulfuric acid and the NaOH, this reaction is it's not 1-to-1, it's 1-to-2, and it's in that case you don't apply M1V1 equals M2V2 or MV acid equals MV base. You need to do something to take care of the stoichiometry in the reaction. Okay, so let's take a simple example for titration. Here I have a burette, and I think you know what is a burette. It's that long glass tube that you put your analyte in. Okay, and there's also a conical flask at the bottom of this burette, and there's also here your valve that you use to control the titration. In the burette, we can put the substance with the known concentration. In this case, we take an example of 0.1 molar NaOH. So that's a solution that we know the concentration, we are sure about it. And the general name for that is called this is called the titrant. And generally this is called the titrant. Okay? In the bottom, in the conical flask, I'm adding here 25 milliliter of HCl of unknown molarity. So this is the idea of titration, is you do titration to know the molarity of the unknown substance, which is in this case the Ionization. So in titration, we have two things. We have something called the titrant. In this case, it's the sodium hydroxide. It's this solution that you put in the burette. Okay? It could be NOH, it could be anything else. And in the conical flask in the bottom, you put your Ionization, which is the material or the substance that you want to analyze. So in titration, you titrate an Ionization using a titrant with no concentration. This reaction is 1-to-1 because 1 mole of sodium hydroxide reacts with 1 mole of HCl to produce product. So here you can say at the equivalence point or at the end point, the number of moles of the acid is equal to the number of moles of the base. And that's the idea of titration. Now let's imagine that we did titration and we discovered that actually the color change happened at 15 milliliter, 15.5, let's say, milliliter of NOH. Okay, that's the volume that it took to completely neutralize the acid, and this is where the end point. So in this case, because number of moles is equal M times V, so we say MV for the acid is equal MV times the base. So because this is 1-to-1 reaction, and so you just plug in the numbers. In this case, the molarity of the acid is unknown, so the molarity of the acid times the volume of the acid, which is 25 milliliter, is equal to the molarity of the base, which is 0.1 molar, times 15 milliliter. And that's the nice thing about these equations, that the milliliter goes with the milliliter. You don't have to change units, and you will find your answer, the molarity of the base, molarity of the acid, to be in units of molarity. And then you can do the math at home. So that's a simple reaction, a simple titration reaction. Here we have a question that looks a little bit different. In this question, it says, in a titration experiment, a student finds that 23.48 milliliter of NOH solution are needed to neutralize 0.5468 grams of KHP. KHP is potassium hydrogen phthalate, and the good news is that this material reacts with 1-to-1 ratio with sodium hydroxide. It says, what is the concentration or molarity of the NOH solution? So this question is flipped. Here we don't know the molarity of sodium hydroxide, but we know something about the acid. This question is simple to the previous question. The only difference is that you don't have volume of the acid, you have grams. So the question here is that says NaOH plus KHP So this question says that you have NaOH plus KHP should give salt and water, which is the salt of the potassium hydrogen phthalate. And we have 23.48 milliliter of water. We have this grams of KHP. I have calculated, or you should be given the molar mass of KHP. It's 204.2 gram per mole. So this number was missing from the question, but I think because it was been explained in the book, he just realized that you know this number. But in the exam, you should be given this number, the molar mass of KHP. And I'm asked about the molarity of NaOH. So this question, because the reaction is 1-to-1, then you say the number of moles of the base is equal number of moles of the acid. But here you can say, yeah, number of moles of base is M times V. But the number of moles of the acid, you cannot say M times V because you're not provided information in terms of molarity and volume. You are provided information in terms of grams and molar mass. Then you can use the MV in liters, of course, and this is important. Should equal mass divided by molar mass. Okay, so you can basically solve this by itself, the mass divided by molar mass. You find the number of moles, you equal it to the left part, and then you have this volume, you convert it to that liter to liter, and then you find your molarity. We are going to solve this, of course, in class, and we're going to also solve this question about the titration of sodium hydroxide with H2SO4. And that would be the end of this chapter, chapter 4. Thank you so much for listening to my lectures, and I wish you all the best in your exams and your end-overs. And have a great day. Thank you.